Hi students, this is AJ sir. Let's study 9th standard ICSE Math chapter 17 exercise C and D of circles. Also to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information. For the C exercise, you have to practice theorem number 27, but for theorem 28, you need to know only the statement, not the proof. When you practice solved examples, make sure you read these notes as well, which are very important. 17C. Mark this sum as IMP. Now this is a square inscribed in a circle. So the circle is called a circumcircle with center O. First we have to find angle BOC. Now it seems that BOD will be the diameter of the circle as well as the diagonal of a square. Even AOC would be the diagonal of the square. And diagonals of squares are perpendicular to each other. So angle BOC will be 90 degrees. But we can't assume this. We'll have to prove that it is 90 degrees using congruency of triangles. So when we extend BO till the circumference of the circle, even though in the diagram it's clearly visible that BOD is a straight line, at this point it's an assumption. So I cannot conclude that BD is a diagonal. What we'll do is, we'll prove triangle BOC and triangle DOC congruent. So we've got BC equal to DC, side of a square, and BO is equal to OB, radii of the same circle, and OC is a common side. So these two triangles are congruent by SSS test. So by CPCT we can say that this angle is equal to this angle and also this angle is equal to this angle by CPCT. Again, you cannot simply say that this angle is equal to this angle, but this plus this is 180 by linear pair. Again, you would be assuming that BOD is a straight line. We can't assume that yet. Rather, we can say that this angle plus this angle is 90 degrees because we know each angle of a square is 90. So this becomes 45 and 45. Similarly, even this will be 45. So if this small angle is 45 and this is 45, then by angle sum property, we can say that angle BOC is 90 degrees. So we have actually solved Roman number 2 first by finding angle OCB. And then by Roman number 1, this angle is 90 degrees. Next, we have to find angle COD. Well, we already proved that angle COD is equal to angle BOC, so even that is 90 degrees. Finally, Roman number 4, how much is angle BOD? Now we know that angle BOD will be 90 plus 90, which is 180. Don't assume that it was already a straight line. No. First we've proved that it is 180 degrees, and now confidently we can say it is a straight line and that it is indeed a diameter of the circle. Next, 4.1. Here the diagram is given and they've given the value of angle AOB. They've asked for BOC. Well, the theorem says that equal arcs subtend equal angles at the center of the circle. So if the arcs are equal, as mentioned in the question, even the central angles will be equal. So Roman number 1, angle BOC is 48 degrees. Roman number 2, they have asked for angle OBC, this one. Now that's a typical way of solving this. First of all, in triangle OBC, OB and OC are radii of the same circle. That means it's an isosceles triangle. That means this angle is equal to this angle. Let's assume them to be X and X. And we already know the central angle, which is 48 degrees. Now angle sum property, x plus 48 is 180. Then solve, get the value of x, which will be the value of angle AOBC, 66 degrees. Roman number 3, how much is AOC? Well, do mention angle AOC is equal to angle AOB plus angle BOC. You have to mention all that, and then we write the answer as 96 degrees. In Roman number 4, they've asked to find angle AOC. No, OAC, sorry. OAC. So again, this is similar to Roman number 2. In OAC, we will take triangle OAC, which is an isosceles triangle. Assume angle A and C to be y and y each. Don't use x again. And central angle is already known. Angle AOC we have already found out to be 96 degrees. So we use angle sum property and get the value of angle OAC. Note that when I use angle sum property, I am using single letters for angles, which is fine because I have already mentioned the name of the triangle. So there is no confusion there. Next question 5. Diagram is given. Now the ratio of the arcs are given. Arc AB is bigger than arc BC. In fact, the ratio of their lengths is 3:2. Now there is a property that whatever is the ratio of the arcs will be the same ratio for the central angles that they subtend. So the ratio of the central angles is equal to the ratio of the arcs, which is 3:2. Now angle AOB is already given as 96 and angle BOC is asked, so we can cross multiply and find that. And then in Roman number 2, they've asked us to find angle ABC. Angle ABC. Now there is a direct formula to calculate it, since we know angle AOC, which is an addition of 96 plus 64. There is a direct formula to find angle ABC, but that direct formula is in the circles chapter of 10th standard. So we can't use it now. So we'll have to do a longer method here. We'll first find angle OBA, then we'll find angle OBC, and then we'll add them. And how to find those angles? Well, just like we did in the previous sum, we'll show that angle OAB and OBA are equal, isosceles triangle property, then angle sum property. Same thing we'll do in triangle OBC as well. So that's how we'll find the individual angles in the two triangles, and finally we will add them to get the final answer. So mark this 5th sum as IMP. Now the 7th sum. Now remember, whenever they say that a chord in a circle is a side of a regular hexagon, that is, we can draw an imaginary hexagon, a 6-sided figure, and AB will be one of those sides. What is the use of this information? Well, we can find the central angle using a formula, which is the central angle is 360 degrees upon n, where n is a number of sides. So for angle AOB, AB is a side of a hexagon. So it will be 360 upon 6, that is, each angle is 60 degrees. The central angle is 60 degrees. Similarly, AC is a side of an octagon. 8-sided polygon is octagon. That means how much will be angle AOC? Can you guess? Come on, calculate and tell me. Well, it will be 360 upon 8, 45 degrees. Great. So we've got both the central angles. Now Roman number 1 and 2 done. Now Roman number 3, angle BOC. Well, just add the two central angles and you get it. And Roman number 4, angle OBC. Keep looking at the diagram. In geometry, we have to look at the diagram several times in the sum to understand it better. How to find angle OBC? Again, we have to consider triangle OBC to solve. First we use isosceles triangle property, then we use angle sum property, and we get the final answer. Now in 17D, there are many sums which are of exactly the same type as in exercises A, B and C. So we are going to cancel those sums. So cancel 3, 4, 5 and 6. If you wish to do it, you can, but it's the same type. So I'm reducing your homework here. We're going to do the second sum first. Mark it as IMP. It's a proving sum and the given is not given. So the given is that there are two circles, I'm assuming centers O and X. They are congruent, that means the radii are same for both the circles. And they have two chords and they are also congruent. We have to prove that their corresponding central angles, that is angle AOB and YXZ, are also equal. So given to prove, and the proof now, we'll prove these two triangles congruent by SSS test. Radii, 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 chord, chord, all are equal, all are given. So the two triangles are congruent, so the central angles are equal by CPCT. And don't forget to write the final statement in English, otherwise you'd lose some marks. Next, the eighth sum. Again, eighth sum is similar to a sum we had done in the previous exercises. Here, the chords are equal. That means they will be equidistant from center O. That means OP is equal to OQ. That will be useful because that means triangle POQ is an isosceles triangle. And they have given angle POQ. So we can assume angle OPQ and angle OQP as X each. By angle sum property, we can find the value of angle OPQ. And how much is angle OPA? It's 90 degrees because OP is the bisector of the chord. They have mentioned that P is a midpoint. And bisector from the center of the circle always is perpendicular to the chord. So if OPA is 90 and OPQ is 15 after calculation, how much is APQ? 90 minus 15, that is 75 degrees. So that's the way we will solve it. And here are the steps. Remember, here the reason is equal chords are equidistant from center of the circles. And now the 10th sum. In the 10th sum, they have given the ratio of the arcs in fraction form. And we have to find one of the angles. Now, as I have already mentioned, whatever is the ratio of the arcs of a circle will be the same ratio for the central angles of that circle. So, this is the diagram. This is what is given. So, we can then state that similarly, central angle ratio is 2 ratio 3 ratio 4. That is, this is 2x. This is 3x and this is 4x. That's what we have assumed. X is the common multiple we have assumed. But the sum of all angles around a point or about a point is always 360 degrees. Just like sum of all angles on a straight line is 180. So that means 2x plus 3x plus 4x is 360. Get the value of x, substitute and get the value of angle BOC, which is what is asked.